I'm Alex Larson, dietitian, Ironman finisher, and host of Endurance Eats, the podcast where we break down the science of endurance nutrition and turn it into clear, practical nutrition advice to revolutionize how you think about fueling your body. So grab a seat, or keep moving if you're out training, and let's get started. Welcome back to the Endurance Eats podcast. We are kicking off season 2 with a topic that is not my area of expertise, ketones. I've read enough of the research that I have a general understanding, and I think we've all seen the ads on social media for ketone supplements promoted by a number of pro athletes. So what's the deal with them? We're going to find out, and that's why I'm joined by Dr. Jonathan Little, a professor in the School of Health and Exercise Sciences at the University of British Columbia. John has published over 200 peer-reviewed journal articles in the areas of exercise metabolism, nutrition, type 2 diabetes, obesity, and immunology. His laboratory has conducted pioneering studies exploring how exogenous ketones impact metabolic control, cardiometabolic health, immune cell function, and inflammation. Here we go, season 2. Let's get an update on the ketone craze and if there's validity behind the hype. John, I'm so excited to have you here today. I think people are dying to know about what is going on with the ketones. As an endurance athlete myself, I see on social media and everywhere these ads, often like promoted by pro athletes for ketone supplements. And I want to just lay it all out there. What do we know in the research? Are they all they're cracked up to be? So, John, thanks so much for being here.
Yeah, thanks for having me, and look forward to the discussion today. I'll start by saying I am not a pro athlete, so I'm a scientist. So I won't have the pro athlete perspective, but I'll have the scientific perspective and maybe as a former endurance athlete perspective.
Love it. Love it. So let's just get out here and set the stage. Like, what are ketone supplements? Like, how did they come about? How do they work, especially compared to carbs? And what do they even do?
Yeah, so that's a great question, and I think it sometimes gets confused in the online world, even in the literature, on what is an exogenous ketone supplement. So they can mean many different things. I guess in the big picture, it's a ketone that you can drink or eat, I guess, and most of them are in the form of drinks. So ketones, there's 3 different types of ketone bodies. Your liver produces these naturally all the time at a very low level. And then if you're fasting or starvation or on a ketogenic diet, your liver produces more of them. And those ketones are beta hydroxybutyrate, that's the most important one, acetoacetate, those float around in your blood, those two, and then acetone, which is you breathe off, right? That's the nail polish remover smell. So BHB, or beta hydroxybutyrate, is the most important one. So there are supplements which you can take which contain BHB or a precursor to BHB. So you can essentially drink something that will raise ketones in your blood. So it's kind of a unique situation, right? So normally you would only ever have these around if you were starving, fasting, or on a ketogenic diet, and your liver would be producing those. And now, after the invention of these supplements, you can drink it and get your body into this kind of unique state, right? You have ketones floating around in your blood, but you're not starving or in fasting or in ketosis. So I think the overall premise of this is that it's a new fuel source, right? I've heard it called the 4th macronutrient, right? We have carbs, fat, and protein. Normally, your body would only be able to have ketones around if your liver was turning fat into ketones, but now you can consume them. I think we can probably categorize them into 3 categories. So there's the most studied, the most potent, and the most money has been spent on the development of what's called the ketone monoester, KME. And that's the product that comes from Ketonaid in the US and from T-delta S, or it's called Delta G in the UK. And that was, scientifically backed, formulated, developed over many, many years by 2 prominent researchers. It is BHB combined with this molecule called 1,3-butane-diol. It's an alcohol. Goes into your gut. You break that into BHB, goes into your blood almost right away, within 15 minutes. The 1,3-butane-diol goes to your liver, and your liver will produce that into BHB and give you another one. So essentially, you drink this one drink, and you get a double BHB into your blood. There's then ketone salts. Ketone salts are just BHB with a cation with sodium or calcium or magnesium. Those are less potent than the ketone monoester, but they obviously contain the actual ketone molecule. We can talk a little bit more about those. Then there's ketone precursor molecules. So there's supplements like ketone IQ is one of them. That is 1,3-butanediol. So that's the same molecule that's in the ketone monoester, but it's not an actual ketone. You drink it, it's got to go to your liver and get converted to ketones. There's a couple of other new ketone precursors coming on the market now too, just different molecules that your liver will turn into ketones. And then maybe we could include it just because I know probably some of your listeners have heard of MCT or medium chain triglycerides. Medium chain triglycerides, sometimes people will loop those into ketone supplements. They're not a ketone, but your liver, again, will convert those to ketones. So to summarize that, we have ketone monoesters, most potent, most studied, ketone salts, and ketone precursors.
Got it. And so when people are looking at different ketone products, making sure to understand what type is important.
Correct. And I could probably summarize all the literature there. We need more. This is a relatively new area from a research perspective, but there is the most evidence and studies on the ketone monoester. So probably everything I talk about or we talk about today, you could say that's based on research on the ketone monoester. I don't think ketone salts are really worth any investment for an endurance athlete. And it's probably not because of the ketone, but to get enough ketones, you have to consume a whole heck of a lot of salt with those. I mentioned they're ketone salts. And maybe that could be a problem for blood pressure or whatever, but the biggest problem is for your gut. So to have enough ketone salts to actually get enough of that BHB in the blood system, you have to have so much salt in your GI tract that sucks in water. When you suck in water into your GI tract, you get GI issues. So I don't think any endurance athlete would make any sense to have ketone salt. So we can probably push those aside. And most researchers and athletes, I don't think, are using those. And then those ketone precursors, 1,3-butanediol and the new ones, there's literally zero published research studies, maybe one or two published research studies on athletic performance and those studies. So we kind of don't really know. So everything we're talking about is probably the ketone monoester, which again is I don't have any ties to these companies. So ketone aid or the T delta to S or delta G product.
What's the science saying in regards to endurance performance? Because ketones are very expensive, the supplement products. The consensus is they taste like absolutely terrible. Like, are they worth it?
So maybe we'll just take one step back to look at the science and the theory behind this. So really this all started with, there was one big paper in 2016. So this came from the group in Oxford who's developed and invented the ketone supplement. And it made a big splash because it showed in a prominent journal that consuming this ketone monoester supplement improved endurance performance in decently trained cyclists.
Okay.
So they showed improved time to exhaustion, improved time to performance. And they did some fancy metabolism studies with some overreaching claims, but it suggested that the improvement in performance there was related to ketones sparing muscle glycogen. And I'm sure most of your listeners would be familiar with, as an endurance athlete, the concept if you can spare your muscle glycogen, then you can preserve that, you can go longer, you can go harder. So that was in 2016. So this was in the exercise physiology, sport nutrition world is, we've got a new supplement, it spares muscle glycogen and improves performance. Since then, there's been maybe over 20 studies looking at this. Only one other study has ever shown improved performance. So I don't think I think there's meta-analyses pooling all the studies together and that sort of thing. There's no improvement in performance acutely. Now, obviously, when you do studies, every study has different nuance and context, right? So did you feed the ketones with carbohydrates or were they on their own? Was it elite athletes or was it recreational, athletes? What was the exercise test? Was it long enough to see an effect? So there's all of these kind of things that have to go into trying to interpret this literature. But I think it's fair to say that this kind of idea that you're going to take this fourth macronutrient and it's going to improve your performance acutely is probably now fairly well settled that it's not going to improve your performance acutely, and it's not via sparing muscle glycogen. I'll summarize this up too, just so that people know. The same group that showed this improved performance then went on to try to test this more, which is great. Others have worked on this. The reason why I don't think acute ketones are going to improve your performance is when we do the math and calculate how much your muscles can actually use of this ketones, the ketones are contributing so little to the overall energy contribution of exercise that it's not going to matter. So when we actually trace this, so you can put a label on the carbon on the ketone in the drink. You drink it, then you measure the CO2 you're producing, and you can track how much of the energy that I just used during exercise comes from the ketone. And it's about 3 or 4% of the total energy comes from the ketone, right? And it doesn't really look like that changes if you drink more ketone or less ketone. So it's just kind of always the same. Whereas I'm sure your listeners would know, we normally think about your energies coming from carbs and fat. During exercise, especially if it's vigorous or hard exercise, almost 100% of the energy is coming from carbohydrate, and that is a very efficient fuel to use. When you're doing endurance sports, then it's a mixture of carbs and fat, but it would be something like 70-30 carbs and fat, and then ketones can contribute an extra 3% of the overall energy. So that's why I think that it's not really having an effect, because your muscles just can't use it during exercise. And then there's really cool studies where we've isolated mitochondria from muscle and fed it ketones outside of the body, and your muscles can't really use the ketones very well. So I don't think it's this extra fuel that's going to be boosting your performance that way. So that's probably the summary of that and why it's the case. There may be some contexts where ketones or some new applications of ketones in exercise where maybe we want to explore that or take a look further.
Are ketone supplements something that an athlete that's on a ketogenic diet would be using then? And would they get more benefit from it?
Yeah, great question. There's been a couple of studies on that, but not many. And I think this is where I'll get into a little bit of my metabolism interests and expertise, I suppose. It sounds good on the surface, right? I'm on a ketogenic diet. I use ketones, so it would make sense. There's maybe 2 or 3 studies that look at this. It does not look like that is the case, that the ketone supplements will help the athlete on a ketogenic diet. And here's one reason why. We study this. My lab is primarily focused on the metabolic effects and the potential metabolic therapy using ketones. When you're in ketosis on a ketogenic diet, those ketones are coming from fat, which is liberated from your adipose tissue. So your adipose on a ketogenic diet, your adipose is constantly releasing fatty acids. Other tissues use them, but your liver takes those fatty acids, converts them to ketones. And that's why it's called a ketogenic diet. You're in ketosis. Well, when you consume exogenous ketones, one of the weird things that happens with consuming exogenous ketones is your blood insulin levels go up. When blood insulin levels go up, that inhibits lipolysis. So it starts to shut off the adipose tissue from releasing those fatty acids. So my interpretation of that would be, if you're on a ketogenic diet, high lipolysis producing ketones, and then you take ketones from the outside, you'll be shutting off your own endogenous ketone production for a certain period of time. Then you'll have to kickstart it and get it back in gear. So to me, it doesn't make that much sense from the metabolism. Hopefully that explanation made sense. The other thing that we know from ketones is when you're in a state of fasting or starvation or a ketogenic diet, the ketones tend to build up inside your muscle. And so you're kind of saturating the system already. So adding more is just not going to probably do anything. So I think if you're already on a ketogenic diet, because that's what you're doing for your ultra endurance performance or weight loss, or it makes you feel better, taking ketone supplements not needed and possibly even counterproductive.
Interesting. That's fascinating. From the consensus is they're not worth it. So far of what I'm hearing. I have seen some research studies suggesting that ketone supplements impair performance, especially in workouts or races that are very high intensity. Are there scenarios where ketones would be better suited?
So, and that impairing performance is probably from one of our original studies. So in that 2016 paper that I mentioned before, they had this interesting statement in the discussion of their paper. And they say that The mechanism by which ketones might be sparing glycogen is actually by impairing or inhibiting glycolysis. So glycolysis is the pathway that you use to get energy from carbohydrates in the cytosol, so before the carbohydrate gets into the mitochondria. One of my undergrad students read that and said, hey, if that's the case, wouldn't ketones impair high intensity exercise performance? And I said, yeah, it's a good hypothesis. Let's test it out. So we went online, purchased some ketone supplements, got them in the lab, pilot tested them out. Then we ran a study taking ketones and doing a high intensity time trial. So a time trial that takes you about 10 or 15 minutes, where it'd be highly reliant on that carbohydrate and glycolytic pathway. And lo and behold, we saw that it impaired performance. So I think if you're doing high intensity performance, ketones probably are not for you. And again, what is high intensity? I would say there, again, we don't have all the data here, but if you're like a pretty good runner running 5K or 10K, you're going at such a high intensity there, you want to be burning as much carbs as you can. So inhibiting that with this ketones is probably not good, or anything shorter than that. So I think you're correct there that nobody would really suggest that we use ketones for high intensity performance. Again, there may be some nuanced situations where we haven't yet studied this, ultra endurance athletes or something like that. The other area where maybe there's a little bit of interest would be around ketones. Your brain likes ketones, right? So there's one or two studies that show that maybe taking ketones during exercise might improve your cognitive performance or your decision making after exercise or late in the exercise. So again, this is perhaps stretching a little bit, but it's saying, hey, if you're in an endurance sport where maybe making a pacing strategy, a 90-minute soccer game or something like that, late in the game, if you can improve your cognitive performance, then this might be a place where ketones could have a play. But I don't think it's because it's improving your metabolism or your efficiency or energy or anything.
Yeah, and I feel like caffeine has that effect too with cognitively.
Yeah, so great point. And this is where, we won't get into all the details, but this is where like you understand the science, or you read a paper, or you read a media report from a paper, there's always nuance and context here, right? So a great point with caffeine, right? Have studies compared optimal carbohydrate dosing with optimal caffeine dosing, and then seeing if ketones have any benefit on top. But that study hasn't been done. There's been some studies with optimal carbohydrate, I think, performance, and then adding ketones on top. And again, they don't seem to have benefits there. But it's a great point, and it depends on the question in your research study and what you did. But caffeine, I think, would be a much bigger impact on your cognitive and mental performance than ketones would be.
I just got to say that's very cool that an undergrad student was reading that study and just got curious, you know what I mean? And then you just took that and studied it and were able to kind of give that answer of like, oh yeah, his hypothesis was correct in that ketones wouldn't benefit high intensity exercise.
Yes.
And like just now, being curious of like, okay, does a optimal carb and caffeine intake with ketones, does that make a difference as well? So like all of those things that we get curious about, and that's what science is all about, and researching those little minute details of combining different things.
Exactly. Yeah. And then I'm sure all your listeners are familiar with this, but I think, this is one problem with science is we can't do the well-powered studies for every single scenario for every single person. Right. So again, I would say, experiment yourself and see, right. Because maybe, there's not a study out there with all your specific nutrition and fueling strategies that you can lean on the science, but you need to experiment yourself to really figure out what's going to work for you.
Yeah. And that's the thing about nutrition that I preach over and over. And like, it's such a individualized thing, and we have to be able to take the science and translate it to that everyday athlete and how to navigate doing it in a way that's easy for them to implement, making it very doable for them to do consistently. Exactly. So it's complicated, but at the same time, my goal is always trying to simplify things. Is there any difference in male athletes using ketones versus female? I just seem to, one of the questions I got from someone on Instagram is that they see a lot of pro male athletes that do the majority of the sponsored marketing. We don't see a lot of women promoting it. has that been studied in like difference in female and male athletes?
Yeah, great question. And again, like a lot of things in exercise physiology, nutrition research, we don't have enough
Yeah.
studies looking at sex differences. And in general, females are underrepresented in many of the studies. Unfortunately, I can't say that there's studies looking at those sex differences. There are studies that include both males and females. And in our studies, we've included both males and females. I don't think there's any signal there to suggest that there's impact differently between biological sex. We do know there's differences in ketosis between males and females. So females tend to get into ketosis faster when they fast. They have a greater increase in ketones and a greater decrease in blood glucose. And that's probably because we know in general females are better fat burners than males. So there's maybe some theoretical basis for a sex difference there. But again, very important for the listeners to understand that exogenous ketones are very, very different than endogenous ketosis with a fasting or ketogenic diet. So we have those differences in endogenous ketosis. When a female fasts, for example, they will tend to get higher ketones than when a male fasts for the same amount of hours. But that is a very different metabolic environment than quickly chugging ketones and having them enter your system through the gut. So we just don't know the answer there to a sex difference.
Yeah, I definitely tend to see more males doing a ketogenic diet in athletics than I do women.
Yeah,
Sure.
and I would agree with you there in kind of that ketogenic diet, ultra space or something like that. There tends to be more males doing that. So,
all right, let's talk a little bit about recovery.
okay.
Any benefits there in terms of like post-exercise recovery and using ketones?
Yeah, so that's where the kind of research has gone in the last couple of years. So I could probably bin this into 4 or 5 different categories here. So,
Okay.
So bear with me as we go through the possibilities for recovery. I'll preface this by saying the potential for ketones in recovery is still very early days. Most of these possibilities, these buckets that I'll put things in, are based on 1 or 2 studies, right?
Okay.
So this is not set in stone. We don't have enough research. I also think, again, I have no ties to the supplement industry. There's a little bit here of, we developed this supplement. It doesn't work for improving acute performance. What else can we repurpose it for? And let's repurpose it now for recovery. So I think that's important for a listener to understand that maybe some of this is like, we've spent all this money, all this marketing, and it doesn't work. Like, taking ketones is not going to improve your endurance performance, but maybe it can help your recovery or some other aspect. So I think that needs to be considered. But here's where potential recovery, it can come in. There's some evidence that ketones can improve muscle protein synthesis, muscle recovery, reduce muscle breakdown. Again, and this makes a little bit of sense, right? Ketones would only ever be present if you were fasting or starving. And it makes a bit of sense that evolution might have set a system up to say, hey, this signal is floating around in your blood, ketones, this means that you're starving or fasting. Let's preserve some of our muscle, or let's hang on to some of our muscle so we don't lose it. So I think that there's probably some signaling and some evolutionary benefit to that. A couple of studies have shown after exercise that ketones can improve some of the signaling in your muscle that promotes this muscle protein synthesis. One study has actually measured muscle protein synthesis and shown no effect. So I think it's a bit of an unknown there of whether that will be the case. I think protein is probably way more important than ketones.
Okay, like leucine is also one of those that triggers muscle protein synthesis. So I'm like, okay, is it trying to mimic what leucine does here?
Yeah, it's probably via a slightly different molecular mechanism, but you're exactly right. I think leucine would be a sledgehammer and a ketone would be a pinprick on muscle protein synthesis. So it's probably not that, but again, there's some interest there. We're running a study right now measuring muscle protein synthesis after exercise with optimal protein to see if we can get any added benefit. If you just study ketones on their own with no protein and you see a signal, you might say, oh, this is amazing. It's activating mTOR and doing this. But most athletes will just consume protein because we know that that's better. So that's one angle, maybe. There was a few studies showing enhanced muscle glycogen synthesis. So for the endurance athletes, that might be beneficial, right? If you're in a
Mm-hmm.
multi-day race or you're doing a workout in the morning and then you've got another workout in the afternoon or something. Those data probably, I think, are only under certain very contrived conditions. So when you drink ketones and you drink carbohydrates or eat carbohydrates, there doesn't seem to be any effect on muscle glycogen synthesis. The study that showed that you had to infuse glucose to a very high level and then drink ketones on top of that. So that's not a situation that we normally are in where our glucose is getting infused into our system. So I don't think there's any muscle glycogen resynthesis benefits. Two areas that are getting some interest lately. One is ketones for sleep. So I think I've heard this, that some of the, Tour de France or pro cyclist teams are using these ketone supplements. There's one study that's come out now in trained athletes where having ketones before sleep improves sleep efficiency, improves sleep quality. Again, in the context of a situation when the athletes did an evening hard exercise session. So and many people probably know this because sleep is really popular now in terms of optimizing. Doing a hard exercise session in the evening is probably not the best for your sleep. However, many athletes have to do this.
I'm one of them. Every once in a while, next thing you know, it's 9 o'clock. I'm like, oh shoot, I gotta get my workout in, and it's not ideal, but I get it done.
So one small study, 10 athletes, but very well controlled. If you do the evening exercise session and you have ketone monoester before sleep, it seemed to improve sleep efficiency, sleep quality. So I think there's some, again, a signal there. It's one study, so it could be similar to the original 2016 paper where it made a big splash because it improved performance, and then we found that it wasn't the case. But that's something that I think needs further study.
Is there a theory why it would improve sleep with that? I mean, is it brain related?
I think so. So this study didn't measure it, and obviously they speculate on what it might be. But I agree with you that it's probably something related to ketones in the brain, and it's having an effect there. So that's an area of intrigue that might be coming out. And the other area that's made a bit of a splash lately is ketones after exercise can increase erythropoietin or EPO. So EPO, many people know as doping when you take EPO as a exogenously, but you produce EPO naturally, and that's how altitude training works, right? You go to altitude, produce extra EPO that promotes the formation of new red blood cells. After a long period of time or a certain period of time at altitude, you get more red blood cells, you can carry more oxygen, that should improve your endurance performance. So a few studies now have shown that if you have ketones after exercise, you get an augmentation in EPO. I don't know, so it hasn't been shown yet whether over time that would lead to increase in red blood cells and improved performance. I have my doubts about that because when you look at the altitude literature, you need to spend, 20 hours a day at least at altitude for a minimum of 4 weeks, or that to get enough EPO, to get enough stimulus to get red blood cells. So whether this, slight increase for a couple of hours after exercise with ketones is going to be enough to see a benefit or see that mechanism come through, I'm not sure, but it's intriguing, I suppose, that ketones seem to be doing something. So I think those are the two areas in recovery, the sleep and the EPO angle, where maybe this has an effect. If I were to be weighing up spending my money versus not, I think I would wait for a few more studies to come out. Maybe I'd try a, ketone shot before sleep and see if it, anecdotally, or if my sleep tracker showed me that it had improved performance or improved sleep quality or something. Maybe that's a little harm, possible benefit scenario where the literature is leaning.
Yeah, I feel like when there's any new rave thing out there where they're touting, oh, we have this new research, where I'm always like, I'm skeptical and I'm gonna wait and see what comes out in additional studies. That, to me, that's how I always. It's good to be skeptical a little bit in anything new that comes out, especially if it sounds a little too good to be true.
Yeah, I mean, I guess I'm a scientist, so I'm kind of bred to be skeptical, but I think you're right. So, I mean, there's different perspectives there, right? So, someone might be like, one cell culture study shows me some plausibility. I'm doing it, right? Because I want to be ahead of the curve, or, I need to have 10 randomized control trials and a meta analysis to tell me whether I'm going to use this or not. I don't think you should be on either end of that, probably
Yeah.
somewhere in the middle. But
Yeah.
yeah, one study probably doesn't sway me. However, I think also you weigh there, like, what's the potential negatives there, right? So I think taking ketones during your race, the potential negative is it impairs your performance, as we talked about,
Yeah.
or it causes some GI issues.
Let's talk about the GI implications that happen with ketones.
Yeah, so we already kind of touched on the ketone salts. So again, if you're purchasing these things online and you're like, oh, exogenous ketones, they're not all the same. So you got to look and see. I would say the salts, it's not because of the ketone, it's because of the salt. It is not going to be conducive or not going to be something you want to do. The ketone monoester tastes horrible. I don't think we've ever had anybody in any of our studies who said, I like that. I would like to have that again. So some people can tolerate it, better than others. It tastes horrible, but that's not GI issues. That's,
Yeah.
I think especially a lot of athletes will do anything to get a performance. The signal on GI with ketone monoesters is very small. So, we'll do a study and maybe we get a statistically significant difference between having water and having a ketone monoester in your GI symptoms. The way you measure this, the validated way, is you have these scales that are 100 millimeters long, and you ask about your urge to vomit and your bloating and your nausea, and the participant or the athlete puts a mark where they feel on the scale. So the closer it is to the right side, the 100 millimeters, that gives more signal. And it goes from no symptoms at all to like the worst nausea imaginable. When we do that in a validated way, we often get a statistically significant difference. The ketones are higher than water or placebo, but practically it's not that relevant. So the scores are all very low. They're all down in the 10 or 15 out of 100 scores, and many people are at 0. So so I don't think that, yes, it'll be a statistically significant difference, but it's not that the ketone monoesters are really causing too much GI distress. So I don't think that's a concern with the ketone monoester. One, nutrition, as you know more than me, is complex and there's nuances. So if you're using this in recovery, for example, we just talked about, I think you'd want to consider or work with a nutritionist to understand, well, now I'm having something that tastes horrible after my workout. Does that impact what else I eat that day?
Yeah, people already don't have much of an appetite post-workout, and then you're having to eat this really awful thing.
Yeah, so I think that's where it becomes nuanced, but I don't think that GI issues with ketone monoester are a real, like, GI upset is not an issue, even though there's a little bit of a signal there, but it's not a huge effect.
Yeah, and you and I kind of talked about this before we hit record of sodium bicarb. Sometimes people will pair that with the ketones.
Yeah, so I don't want to go down too much of a rabbit hole of acid-base balance here, but when you consume the ketone monoester, beta-hydroxybutyrate is an acid, beta-hydroxybutyric acid. So you consume that, it actually drops your blood pH a little bit. When you drop your blood pH, the response, the homeostatic response, is you produce more carbon dioxide and you breathe it off. You try to buffer it by breathing it off. So we've actually seen this. This is studies in collaboration with Dr. Martin Gabala's lab at McMaster. When you take the ketones on their own, your blood pH drops a little bit, ventilation actually goes up, and heart rate goes up. So and those kind of things go in concert. So even this is at rest. So if you take a ketone, your heart rate will go up at rest, and your ventilation tends to go up. We think it's to try to get rid of this acid, and we've even seen that this might carry over to exercise in certain situations. To me, that's not a great response that you want to have. You don't want your heart rate higher and your ventilation higher during exercise. So we had one study published where that was our conclusion, that ketones don't impact performance, but they increase cardiorespiratory strain during exercise. Now, some studies have shown that, others have not. So again, it's a bit nuanced. But then the theory was, well, what if we take ketones with bicarbonate? Sodium bicarbonate is a base, so the ketones would be making you acidic. The bicarbonate would be bringing it back up. It would be neutral. Now we could see the impacts of ketones when pH is neutralized. So we've ran one study on that, and again showed that it didn't have an impact on performance. Actually, both conditions, it impaired performance in that study in our hands. There was one other study by a different group that showed that you could improve performance when you did this ketone bicarb, and then another study by that same group showing that it didn't. So I don't think it's the case, and that would be one related to GI. Like, it's very widely known that sodium bicarb has GI issues. I know there's some new slow release formulas and that sort of thing that may be better there. But I would never probably tell an athlete to say, take ketones, which taste horrible, and have a little bit of an impact on your GI, and take it with bicarb, which you really have to test and trial and dial it in so that you don't have GI issues, all to get this not really, I don't think, real effect of ketones for improving your endurance performance. So I think that would be a scenario where it wouldn't be worth it. And if any of your listeners have tried bicarb or do it, like, some people can do it, but definitely that is something you want to practice and try. And then, as we all know, I used to be a competitive distance runner. You get more nervous on the day of a race, and that often messes up with your gut a little bit. So you might try bicarb and have it dialed in, and then on the day of a race with extra nerves, it doesn't pan out.
It doesn't go down very easily. Yeah.
It's a tricky one. So I don't think I would suggest that strategy of ketones plus bicarb, but it's a very interesting scientific way to try to isolate the effects of ketones without the pH disturbance.
All right, so your expertise also lies in type 2 diabetes, and I want to take advantage of that and ask if there's any benefits for endurance athletes that have like pre-diabetes or type 2 diabetes to use ketones.
Yeah, great question. And again, this is where the majority of my research in this area has been. And that was because that same undergrad student who came up with the hypothesis for the high intensity exercise, we happened to measure blood glucose in that study. And this is in healthy young people. And taking the ketones lowered their blood glucose. And that was intriguing to us. Again, we went back into the literature, and lo and behold, for 40, 50 years, we've known that if you infuse ketones, it tends to drop glucose in the blood. So we quickly started trying to follow this as a potential way to lower blood sugar in people who have high blood sugar. So we're doing the majority of our studies there. We just published a paper in people living with type 2 diabetes showing that the ketone monoester supplement could improve their stroke volume, their the cardiac output of their heart during exercise. So many people living with type 2 diabetes have some impairments or reduced ability to upregulate their stroke volume and their cardiac output during exercise. And we showed nicely in that study that if you had a modest dose of ketone monoester, it improves your heart function or your heart pumping during exercise. So again, one study, but I think there's some mechanism there. The idea there is that your heart can use ketones, and a diseased heart or a dysfunctional heart seems to use more ketones. So if we can, and there's a debate whether that is maladaptive or adaptive, right? Or is the failing heart or the dysfunctional heart using ketones because it has to, or is using ketones causing it to be less functional? And we don't know that yet. But the idea here is giving extra ketones to a heart that could use ketones might improve its function. And it does look like in type 2 diabetes during exercise that was the case. So that's an intriguing area. I think where ketones might come into play, again, in pre-diabetes, type 2 diabetes, we've shown that ketone supplements can lower blood sugar. It's not the same effect of lowering blood sugar as a diabetes medication, but it can lower blood sugar. And then where we think it's exciting is that there's all of these new exciting hormone-like effects of ketones that might reduce inflammation. They may, as I mentioned, improve heart function. They may lower blood pressure. They may go to your brain and help with cognitive function. So they have kind of these pleiotropic effects. So if we were to use them in prediabetes or type 2 diabetes to try to lower blood sugar, we might get all these beneficial side effects. You can think of them as which most drugs don't have beneficial side effects. So that's still early days too. And again, I would say there, for the cost and the taste and the need to have to take them, multiple times per day in order to sustain ketones, it's probably not worth it yet. However, this new study, maybe if you live with prediabetes, type 2 diabetes, and heart failure is another scenario where the heart seems to use ketones, maybe it would help improve your exercise tolerance or your exercise performance.
What's one thing you think we'll understand differently about ketones and performance in the next 5 to 10 years?
That's a great question. I think that ketones on the brain is probably one of the most intriguing areas. I'm not a cognitive neuroscientist, but I have colleagues who are. The easy way to explain it is your brain, everyone says, oh, your brain uses glucose. It needs to use glucose. Well, glucose needs to get pulled into the brain, meaning that you need to use glucose in the cells in your brain, your neurons primarily, to lower glucose in the brain. And then there's a gradient and glucose gets pulled in. And in cognitive dysfunction, in type 2 diabetes, there's metabolic impairments in your brain. You're not able to use the glucose very well. So that pulling in of glucose is impaired. And that we think is linked with cognitive dysfunction. Well, ketones can get pushed into the brain. So if ketones are there, it looks like your brain just takes them up and uses them. They don't need to be pulled in. So the idea there is you could, by supplementing with ketones, you could get more ketones in the brain and overcome some of these metabolic deficits. Again, that makes a little bit of sense evolutionarily. When would ketones be around? Only ever when you're starving or fasting. And it would kind of make sense for your brain to say, I must be starving. I'll have a mechanism to take these ketones up because glucose is limited in those situations. So I think that's an area that's very intriguing, both from a health and maybe from a performance perspective. And I know there's people working, with military and diving, Navy SEALs, divers, and all of these things on the cognitive benefits of ketones in different scenarios. So I think that's intriguing. This recovery angle that I mentioned, I don't know if I'm convinced on the EPO benefits, but the sleep angle might be one where it can be intriguing. I think another thing, just my own opinion or anecdotal thoughts on why do so many Tour de France teams keep using these supplements, or apparently they do, right? Because you see this. I have no idea if they have sponsorship deals or whatever it might be, but I think that ketones are intriguing in those situations because the placebo effect is real, right? We know that there's a placebo effect, and they taste so bad and they're so expensive that it would have a big placebo effect in those athletes, I think, right? So I don't know if that's a future direction, but trying to tease that out to figure out, right? If you're going along and saying, hey, after you finish your race or your first stage of the ride, instead of just make sure you're fueling, here's the food you should eat. It was like, and here's this supplement. It's going to help you recover, and you taste it and it tastes horrible. And that maybe that just helps from a placebo effect, and you get a benefit. And if I was a professional cyclist or professional athlete, I'll happily take a placebo effect as long as it's not having it. If it's legal, and also if it doesn't have any negative effects.
Well, and the Tour de France is such an extreme event. The miles and the elevation and the days after days of riding, those little things, like even if it, like you said, that 3%, 4% potential bit of energy that it provides, like to them, they are looking at the really tiny things that will give them the boost. So I could see from their standpoint why they would use it.
Yeah, exactly. And I kind of mentioned before, if you have everything dialed in, maybe ketones are a cherry on top of everything. But for the average everyday athlete, the science and the mechanism just isn't there.
Yeah.
And I would, if everything's dialed in as a Tour de France athlete, and you have something that you don't think is going to harm and it's legal, why not, give it a shot?
Exactly. But that doesn't mean that everyone should be using
Correct.
them. Yeah.
And money's not an option or not.
Correct. Yeah. When it's just, sponsored and handed out, like it's not a big deal. So fascinating. Honestly, John, this whole interview is incredible. I cannot thank you enough for your time and sharing this. Like I'm I'm so excited to share this with listeners because this just answered all of my questions, because I had seen the overall like consensus of the research and I had my own thoughts, but I'm like, no, let's really deep dive in here. And I feel like we accomplished that today. So again, thank you so much.
Good. Well, thanks for having me, and happy to come back anytime if you have other questions on ketones or anything else.
What a way to kick off season 2. Big thanks to Dr. Jonathan Little for helping us cut through the noise on ketone supplements. Whether you're intrigued, skeptical, or somewhere in between, I hope this conversation gave you some clarity on how ketones actually work and help you make an informed decision on whether or not you want to use them as part of your own endurance journey. I'm so excited for what's ahead in this season. If you liked this episode, do me a favor, leave a quick review, share it on social, make sure to tag me. It's a huge help in getting Endurance Eats into more earbuds this season. Thanks for being here. Fuel smart, train strong, and we'll see you in the next episode.